This is from the 2017 MCAT, Day 2, Question 3, Part D. Now, we're trying to solve, I've got an inequality, I've got some exponential stuff going on here, there's a lot to take in, and I'm also pretty sure that 65 isn't going to go into 4. I don't think 4, because it's odd. So, but they've given me an inequality here. There's a few ways that I can go. I know what I'm trying to do. If they were nice, would be that I'd want 4 to the power of something was greater than 4 to the power of something, and I could use those exponents and make them equal, or make them use the inequality with them. But in this case, I can't do that. So let's just see, what can I do? Hopefully you've seen that 16 is 4 to the power of 2. And so 4 to the power of 2 times 4 to the power of x minus 5 is greater than 65. And remember, if the bases are the same, I add my exponents. So I've got 4 to the power of x minus 5 plus 2. I'm still writing everything in there just that I don't forget anything. And that gives me 4 to the power of x minus 3 is greater than 65. Now, I could say, well, this side here is 4 to the x times 4 to the power of negative 3. And 4 to the power of negative 3 just means it's 1 over 4 to the power of positive 3. Remember, the negative exponent changes to a positive exponent if you invert it, or if you take it down to the bottom. So this is really just 4 to the power of x over 4 to the power of 3 is greater than 65. Now let's just see, what is 4 to the power of 3? So 4 to the power of 3 is, well, 4 squared is 16, and then 16 times 4, 6 4s are 24, 1 4s are 4, 5, 6, so 64. So interesting, it's 1 less than 65. So basically what I've got here is 4 to the power of x is greater than 65 times 64. Sorry, I sort of run out of space. Just make some space there. So, and I know that 64 is 4 to the power of 3. And 65 would be, so 4 to the power of x is greater than 4 to the power of 3 times 4 to the power of 3 plus 1 in brackets. So, it looks to me like x would need to be for this side to be bigger than that side, x would need to be at least 7. So x would need to be greater than 7. Otherwise it's not going to, because there's this plus 1 over here. 1 is 4 to the power of 0, but this is plus, so it's not really going to help me. Okay, so that was one method. Now, you might not have gone down that track. Your mind might have gone differently. You might have gone, well, I just want to get the 16 away, so I'm going to divide both sides by 16, and so you would have said, I've got 4 to the x minus 5 is greater than 65 divided by 16, and then you would have gone, well, 65 divided by 16, oh my gosh, I don't know. We've kind of done some stuff here, so we know it's times, it goes 4 times, but you could have just gone 16 times 2 would be 32, And so then obviously, well, 32 and 32 is 64. So hopefully, just start thinking of your timesing and your bonds and tables and your timesing and dividing. You really need to go over to be comfortable with this as well. So 65 divided by 16 goes 4 times, remainder 1. So I've got 4 and 1/65. No, 1/16. So so it's just a bit more than 4. So this is saying 4x to the minus 5 is greater than 4 and a bit. So if x was 6, then this would just be 4, and 4 isn't greater than 4 and a little bit. So it would have to be, so x would have to be greater than or equal to 7. It could actually be 7 as well. Put that equal in there. And that would be fine. Are you happy with that? I hope there's sort of 2 different ways. So now thinking about it, that's an equals as well. So always think about your answer. Can I go back and change things? It's all good. Okay, A and B are 2 consecutive numbers, even numbers, where B is greater than A. 2 consecutive even numbers. You guys know this. Okay, so if C is B over A minus A over B, give the value of C in terms of A and explain that this will always be an even number over an even number. Okay, so there's 2 things going on here. We just want C in terms of A only. So if A is an even number, then B, and B is greater than A, B would equal A plus 2. I hope you're happy with that. B is larger than A, and it'll be 2 after B. So whatever even number A is, 2 places afterwards would be B. So C can be written as A plus 2 over A minus A over A plus 2. So let's just think about this. Let's rearrange it so that it's, because they wanted an even number over an even number. So let's just make this into a common denominator. So my common denominator here would be A times A plus 2. I hope you're happy with that. I'm just going to use a different color to say I'm timesing this by A over A. Now remember, A over A divided by A is 1, so I haven't actually changed the value. And this side I'm going to multiply by that denominator, A over 2, A over 2. So now remember, there are brackets around here. Don't just go timesing the ones that are next to each other and leaving the rest out. Okay, so you need to make sure everything is kosher and that you are timesing all the right things in. So let's do the multiplication. A plus 2 times A plus 2 will give me A squared plus 2A plus 2A, plus 4 over A squared plus 2A. And then I'm minusing A squared over A squared plus 2A. Okay. Now remember, this negative is going to have to go just to the one thing. So a squared plus 4a plus 4 minus a squared all over a squared plus 2a. Remember, when you've got the common denominator, you keep that common denominator and you just add the numerators, or subtract the numerators in this case. So a squared minus a squared, so that's all gone. And I'm going to have here 4a plus 4. Now, this top half is definitely even because it's times by 4. Okay, and then a squared plus 2a. Now, we know that any even number times itself will always be an even number. And so a squared is even, and plus 2a, 2, obviously a is always going to be even, and 4 times a plus 1 is, so now we need to explain that. Okay, they actually want us to tell us. So 4a plus 1 is equal to actually 2 times 2a plus 1, multiple of 2, always even. And in any case, we were told a is even. We were given that they were even numbers. A is even, and an even number times an even number is even, and adding 2a is adding a multiple of 2, which is also even. So there you have it, that would always be even.